And oh, I'm sorry, I had my headphones. Okay. Hello? Okay, hello? Sorry, I couldn't hear anybody if anybody said anything. Is anybody there? Are you there? Is my speaker?
Yes, we can hear you.
Okay, good, very good. Okay, so I had to mention something. I should mention something about these recordings. I do my very best uh, to keep anybody from from my being able to identify any of you. Okay, so I don't expect any of you to, uh, you can put a fake name up there or whatever you want because I don't really you know take attendance. I make the videos available, and there are some people that have already talked to me that the class time is difficult, and so you're welcome just to watch. And then also, if you if you don't want to be recognized by your voice, which is possible, I'm gonna try to do a very good job of keeping my eye on the chat. Okay, because that's a good way to to type out a question word because I don't see it until it's all done typed. It's all composed. Um, and then all right. So see, somebody asked me about my background. Yeah, this is I don't do Zoom background. I don't do this is a this is a real background. Okay, this is a real background, not a not one of those fake backgrounds. Okay, so um, but anyway, so I started doing this before Zoom had backgrounds. And see how long have they had? Well, before they had the green screen thing, that's a pretty recent thing. But you notice that people always have fuzzy heads. I didn't really like that. But anyway, so I'd like to continue today with chapter 2, and I I went to a really good presentation on the textbook. Let me share my screen here. I want to share the whole screen. All right. Let me put you folks here. The other question is, okay, so can you hear me pretty well? What is my, I'm using this microphone. Okay. All right. I got to make sure not to cover it up. All right. So we're going to do chapter 2 today. And when we do so, I'm going to uh, talk about some of the very interesting things that this revolutionary textbook is trying to accomplish and making things easier for students and us instructors also. And this is similar to Pearson Revel. People that are taking 148 this semester, this is 128, taking 148 are doing Pearson Rebel, which is the old one, and it's a little different. They have a little different philosophy. I like the philosophy of this textbook because in the exercises it encourages you to to run your programs lots of times and experience the errors and keep on doing that until you get the right answer. And this iterative stepwise refinement approach to writing programs is really the best way. So putting limits to how many times you can submit your program, and you submit it and get that kind of stuff is sort of counterproductive to how it really is when you're developing code. So anyway, uh, so so um, so let's let's take a look at chapter 2. And I guess I'm going to assume, I guess I have to assume that this is your first programming class. Okay, so I'm going to assume that, or no, I'm going to teach as though this is your first programming class. Now, probably lots of you have had programming or have had something like programming, or done exercises like coding and so on. So you are just a little bit ahead then. So you can sort of sit back, and this should be like a repeat for you, and that's good. It's nice when you start learning a new subject, if in the beginning it all makes so much sense. Oh yeah, I've had a little bit of this before. I've had a little bit of that before, because then you have your confidence, you understand everything, and it's easy to start absorbing the new stuff when the new stuff comes along. So we're just going to today talk about variables, what a variable is, and assignment statements, basically. And so, there's this concept of a variable that's a bucket that stores like a number, or stores a string or a word or something, stores something, and you can change it, and you change it by assignment statements. And so this here is a bunch of exercises to sort of help you understand the concept of an assignment statement, and variables and what they contain and how their values are changed. Python is a little bit different in that it conceptualizes what's going on a little bit differently than other programming languages, but that's just fine. It's interesting. It'll be interesting when you do learn. If you go into programming, you'll be and you get a job as a coder. You will be learning lots of languages. This may just be your first one. So the idea here is that you go through and you do these activities. You look at them, and you may be able to go through them fast if it's kind of dumb, but you do get points for the participation part. So let's say. So here is a dumb thing where you're trying to keep track of the number of people on the bus. Okay, so let's start this out. I'm gonna click start, and you're driving a bus. The bus starts with 5 people. 3 people get on. So how many people are on the bus now? Well, I guess that would be 8. And lo and behold, that's correct. My gosh. What's next? Now 2 people get off. Oh, so now you only have 6. You see how this variable is changing? And each of these things is like a statement. So 6. Yes. What's next? 4 people get off. Now we're down to 2. 5 people get on. Now we're up to 7. Now 4 people get on. Ooh, 11. So anyway, and then we got all the points. Ooh, look at that. Okay, so it's the concept of a variable. Variable is called number of people. It's just a place there that can store a number, and then there is these things that operate on it, or these are like assignment statements where you're assigning the the current value gets 3 more. The current value, subtract 2 from it. The current value, subtract 2 from it, and so on. So that's the concept here. So here's so an assignment statement is something like where you're actually assigning the value. So this whole thing is an assignment statement. You're assigning an x, which is like what one of these are, what this is up here. You're assigning it to 5, and here you're assigning a new one, y equal to what x is, and here you're assigning z to what x is plus 2, and so these are all assignment statements. And the point of this little box here is that it's not like algebra. Algebra, the equal sign is sort of defining that the left side of the equal sign is the same value as the right side of the equal sign. That's not what this is. This is the right side of the equal sign. You calculate that, you compute what that ends up being, and then the value the resulting value goes over, and that's what the left-hand side is. The left-hand side of an assignment statement will always only have one variable, be one variable name. And then the right side will be an expression. The expression might be just one value, might be another variable, or it could be a big long thing. So it's so that's the point here. And you go through here, indicate assignment statements that are valid. Okay, so these three are valid because you have a single variable on the left-hand side, and the right-hand side is some expression. So valid, valid, valid. And then this one's not valid because what does this do? Does this assign x plus 1 the value 3? That doesn't make any sense, so that's not valid. And this is not valid either because it's got to just have one variable on the left-hand side. Here's your playing computer. X, what's y? I guess it's 10. All right, so anyway, you do that. Select the correct value for x, y, and z after the following statements. Execute. What am I supposed to do here? Select the correct value for x. Oh, x is 3. Y is 5. Z is 4. Is that right? Oh, okay. Oh, now what? X is 3. Y is 7. Z is 4. Okay, well, anyway, so you do those. And, okay, so this is simple stuff, but it's it's reinforcing the concept. So here we do a challenge activity, and so what is this? Assigning a sum. Okay, so write a statement that assigns total coins, that's this variable here, with the sum of nickel count and dime count. So here we have it where we enter in, we ask the user to enter in an integer which we're going to store as an integer in this variable called nickel count, and then we're going to do the same thing for dime count, and then we're supposed to add them up and store that value into total coins. So it's just something like total coins equals nickel count plus dime count. Well, that's pretty easy. Write a statement that assigns cell count with I wonder what would happen if I just did this. Times. It won't let me let me do it. All right, cell count equals. How about? Can I just? No. All right, I got to put it here. Cell count equals. Well, you can just do this. Okay, you can do this, or you can do equals cell count times 5 times 2. I'm just messing around here. Oh, look, it worked. Well, anyway, the real answer should be something like this. Or, really, preferably, you do this like this. Oh, no, not that. 10. So you take the current value of cell count and you multiply it by 10. You set it equal to the current value times 10. And so that's a sort of a shorthand thing. So that's really what they're going to be after in the end, I think. All right. And now, we talked about the letters, not the numbers, but the letters, the variable names, those are in computer language, those are called identifiers. It's a name. And they can't just be anything. There are certain rules about defining these variable names. And they got to start with a letter or an underscore. And then after that, they can have any number of letters and digits and underscores. And it's case sensitive. So this variable is different than this variable in this language. If you're a Windows user, you know that file names and everything are not case sensitive. But in every programming language since maybe Fortran days, it's case sensitive. But in other things, it's not. In database languages, some things are case sensitive and some aren't. So it's not a bad idea to ask, to have that be a question that you ask yourself when you're learning a new language or learning something like commands, operating systems, statements, and so on. All right, so all of these are valid. You can start. An underscore is just like a letter. Okay, so this doesn't work. Sometimes when you have two underscores surrounding a variable name, then it has a special meaning. And it's more. There are some special cases, and I think we might even come across one in this chapter. But still, it's just like a variable name. It completely qualifies as the name of a variable because consists of all characters that are valid characters to be able to make a variable name. All right. There's some, but there are some names that you cannot name variables, and these are these reserved words or these key words. And these are words that are used in the programming language. They mean something in the programming language. And somewhere along here, there's a list of them. Here, Python reserved words. So you can't name a variable capital F and then ALSE. You can name it lowercase FALSE, but not with the uppercase. So it's same with true. I've been bit by that a lot in most languages. When you have a Boolean variable and you want to assign it to false or true, it doesn't matter if you use upper or lowercase or all caps or whatever, but in Python it does. So this is the small set. Now let's say you have a variable and it's you're doing some engineering formula and there's a variable called lambda or there's a constant called lambda and you want to name it lambda. Well, you you can just add an underscore here. That's the convention. If you want to name a variable one of these, just throw an underscore afterwards, and then it'll work. And so there's various conventions when it comes to getting around these kinds of problems here, or these kinds of things that can arise. So here's following what are valid ones. This one, of course, is fine. So is this. So is this. So is this. This is not because it's got a space in there. That's a valid DOS file name, but it's not a valid variable. Oops. This is that. Oh, this is not because it starts with a number. It starts with a digit. Can't do that. Valid. This has a funny character here. You can't have that there. It's invalid. I think this is okay. And this is okay. Print copy, that's nothing wrong with that. So this is sort of now this is just, you know, this is like textbook specific stuff. You know, they like putting underscores to separate, but other textbooks like, oh, you should use bumpy caps or camelback or whatever, where, you know, you use lowercase and then an uppercase, you would say, you know, NUM, uppercase S, you know, TUD, NTS, you know, and so on, and so you wouldn't use underscores. And then there's other sort of things in here that they like you to do, like putting spaces around operators and so on. You know, that's fine. That's I have my own opinions about some of those things, but there's good reasons for. You should just be consistent. Well, you don't even need to be consistent. All right, now in Python they have this. They sort of look at memory differently, and I haven't figured out if it's actually the compiler actually generates different kind of code, a different generates code differently, or it's just a way of sort of visualizing what's going on. But everything is an object, and so if you let's an object represents a value, and it's automatically created by the interpreter when you're executing a line of code. So, for example, when the interpreter or the thing that executes your code executes x minus 4 x equals 4, it creates an object that contains the value 4, and then it names that object x. So you know, if it works the same if you think of it. Well, you have this this object. You create an instance of an object and you name that x, and then you store 4 into it. Or you say, well, I create a new object with it's got 4 in it, and then I name um, that object x. It's kind of the same way of looking at the same thing, but I think there's a value to looking at these at this low level, looking at them as objects, because when we start talking about the paradigm of object-oriented programming, which is how you program these days, it helps. It helps to understand it. So if we go through this thing here, we start out by we're gonna. So these are Python statements that are executing. So the first thing here is when this thing executes, it starts by taking what's inside the print thing here, and you know, evaluating this and creating an object with 4 in it, and the object is just a memory location, and then it executes. Then the print executes, but then the object gets thrown away because it's not needed anymore. Because you aren't naming that 4, the value 4. You aren't assigning it to a variable name, so you can throw away the object, and that just I guess it makes sense, because then that returns that value to object to the memory manager, and helps manage memory. So anyway, then if we go on here, and then we create. I guess we are doing what I said earlier, where if you saw that it creates an object called x, and then it stores 7 in it, and then here it prints x. So it takes x and it prints the 7, but the x object remains because you still maybe want to refer to it later. Oh, and then this is garbage collection. When that's kind of what I was talking about, where once the program is over and you're done, then it doesn't need any of those objects. There's going to be a bunch of objects that are still lying around, and it's up to the interpreter, a smart interpreter or underlying operating system, to go in and collect all those and return them to the memory manager inside the operating system, which allocates memory to new programs when you want to run them. So anyway, and then there's this name binding concept, and that's what I was talking about, where you have the objects and then you name them. And so here the first one creates an object with 25,000, and we name that object Bob's salary, and then we're going to do the same kind of thing for Tom's salary. And then when we set Bob's salary equal to Tom's salary, then Tom's salary, or then we only have one object, and we're able to throw away the object that contained the 25,000. Okay, so that's different. This is different than in other programming languages. In other programming languages, it would just copy the value of Tom's salary into and Bob's salary would remain a separate object than Tom's salary. So there must be some advantage that we realize in the future for Python to be doing it this way. And I'll be on the lookout for it and point it out to you when it occurs to me. So so anyway, so these objects here, these little objects, they each contain a value, but they also have these other properties. There's a type, and so the type can be either an integer or a string. And then there's the identity, and that's what that is that's like the memory location. Okay, it's not the name. It's kind of like it's usually a big number, which ends up being some sort of memory location. So here we have a variable or an object named x. X contains 4, and we can print out x, and it's going to print out a 4. And then we print, and if we just print the value 5, it prints 5. Yeah, that's fine. Now down here, we'll get into mutability and immutable way later on. It's not really important to grasp what those concepts are right now. But here there's a type. This is an object. It's got a type, and the type is integer because it's a number. Here we have another object, and that's a string of characters. So that's going to be a type. This type. So we're talking about these two different types that objects can be. And then objects have an identifier, and this looks a lot like a memory location, a big long string of this big number. So anyway, and here we are. This is just some dumb program that defines 3 variables, and for each of them, we're going to print out the value, we're going to print out the type, and we're going to print out the ID. So when we run this, it looks like this. Well, interesting. Which built-in function finds the type of an object? Type? Oh, yeah. Write an expression that gives the identity of the variable num. ID of num. Yeah, all right. Very good. Okay, this class goes till 4:30. Okay, there's another kind of type, and that's floating point number. So that's when you have a decimal point. And the decimal point can be anywhere. So in other words, there can be lots of digits to the right of the decimal point, or not so many digits to the right, and same with the left or right. So that's where this concept of a floating point comes from. So here's an example of a program that uses floating point And so you have your way of getting input. So I'm gonna pull up my. I'm gonna pull up some. Where's my favorite? Where's the text editor? Text editor. No, I'm gonna use Notepad. Everybody's got Notepad. Note. I have a lot of screens. Notepad. Okay, so I've got Notepad here, and I'm going to copy this thing. I'm going to copy this. Copy. And I'm going to paste it. I have to remember that my picture is right up here, so it blocks stuff in the video, that is. So I'm going to paste that here, and I'm going to save this as something. Test.py on the desktop. And where is that? It's here. And then I want to bring up a command cmd here, and I want to go to my desktop. How do I do that now? I can never remember how to do that. Can I do this? Oh, is that? I don't think this is my desktop here, actually. Oh, it is my desktop. Oh, I didn't realize it was that easy. There must be some sort of... Okay, so I can type in 450. Okay. All right. So this program reads a floating point value from a user and calculates the time to drive and fly. Got it. Okay. So if you're flying at 500 miles an hour, you're driving at 60 miles an hour. Okay, it's a little optimistic, but so and it prints out this. Okay, so what's the point? Okay. Oh, all right. So anyway, that's floating point. We're dividing. Okay, so that's floating point, and then there's another kind, and that's called scientific notation. And so it's like if you have a number like this, which is 6.02 times 10 to the 20. Does anybody know what that is? Where did everybody go? Oh, there you are. I think that's Avogadro's number, if anybody's taking chemistry. So anyway, so the way you would write that is 6.02, and the e is like times 10 to the exponent. The exponent of 10 is basically e. So this e is like times 10 to the. So type as a floating point literal, but not using scientific notation. Okay, so it's like you have one, but then you want to. Can I do some sort of Windows whiteboard? What? I got to practice this. I'll do this later. I'll figure out how to use this whiteboard and utilize it later. So let me just say, okay, so type in 1.0 times 10 to the minus fourth. Well, we're going to, so we want to move the decimal point to the left 4 spaces. So if we go, so it's going to be like 0.000. Let's see. So that would be it was right there. 1, 2, 3, 4. Okay, so that would be. Is that right? Yeah. 1, 2, 3, 4. Yes. Okay. So here you're moving the. Is this right? Yes, it's right. Okay. Shifts the decimal point 4 places to the left, and so here. Same thing with the single digit before the 4 digit. Okay, so this would be, well, zero point zero 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 0.0072. Yeah. Yeah. Okay. So anyway, and this would be 5.4 E. Instead of being right there, it's 1, 2, 3, 4, 5, 6, 7, 8. So 8. Yes. Okay, so anyway, you can figure those out. So this is a program where Albert Einstein's equation, E equals mc squared. This sort of drives home the point. Um, a, a, a programmer does not need to know really even what E equals mc squared means. All you need to know is how to convert E equals mc squared written like this into something that looks like E equals mc squared. So this is the C, and programmers at speed of light, programmers would write that not as a C because we aren't mathematicians. We like nice long variable names that mean something to us to help us remember because we're not so smart to be able to figure this out. But by gosh, we can write a program to calculate that. That's the point. So it's C meters per second squared. Is that C meters per second? Anyway, speed of light, and then this is the let's see, what's the mass? This is the mass. Okay, yeah, you read in the mass. And then this is well, let's run this program and see what it is. So for 0.1, what are you reading in? You're reading in mass. How much mass? So the mass is must be in kilograms. So if you have a 0.1 kilogram, something that's 0.1 kilogram, the amount of energy that, if we were to convert that mass into energy, this is the equation that you'd use. And somehow this this somehow relates to an atomic bomb, I guess. So anyway, you learn a few things when you're in this field. So okay, this talks about overflowing. So it's possible to make your numbers so big that it overflows how big the computer can store. Okay. And so this tells you what those limits are. And so you'll usually get some kind of error like this. And if you get some kind of error like this, there's probably some bug in your program. So, but this is a possible error that you can get, and it usually indicates some logical error in your program, and so it helps you to choose the right type of variable to represent each item. So number of cars would be an integer, because it's just an integer number. Temperature can have a decimal point, certainly. A person's height can have a decimal point. The number of hairs on a person's head, it would be an integer number. And the average number of kids in a household, that can have a decimal point. If you have you can have the average number of kids per household is 2.5 kids or something like that. So that's also would be a floating point number. Okay, are we going to talk about modules next? Oh no, I guess we're going to talk about that later. Oh, formatting. This is the first time we see this. So let's say that we want to print out a number, and we have these things called irrational numbers, which are numbers that go on forever, and this is pi, goes on forever. Or we have these repeating decimals like 4 1/3, looks like this. And so there's a default number of digits that the programming language will print out, but then you might want to do something different than that. And the way you do it is you have this function. See this function. Now, if I were going to design this function, this is what I would name it. But okay. So what this is this just means a floating point number with 2 digits to the right of the decimal point. And so it's and this is what you're printing out. Okay, so let's say you have pi here. Okay, so there's this module called math that we're going to see that later on in this chapter. A module called math, and that allows you to have these names, these identifiers, these variables, or the constants is what they're called. Constant is a variable that doesn't ever change. But that's the value of pi. So you don't have to remember what it is or anything. It's already built into this module called math. It's a math module, and you import the math module, and then your program has access to all the stuff that's inside the math module. But so if we want to print out pi to 4 decimal digits, this is how you'd do it. You'd say single quote, left curly brace, colon, period, 4, because it's 4 decimal digits, F for floating, right curly brace, single quote, dot, and then format, and then in parentheses what it is that you want to print out, what the variable or the value is, the object that you want to print out with this format. So anyway, you have to remember that. It's this one, colon, period, 2, colon, period, 1. So that'd be this one. And then this one is, you have to know about rounding. You have to make sure, okay, so colon, period, 3, it'd be 1, 2, 3, but it's going to round up, so it'd be 9.136. And so here's a challenge activity. So you got to write some code here to compute how many gallons of paint are needed to cover a square foot. Assume 1 gallon, because 360 So you're printing out gallons of paint equals whatever the wall area was divided by 350, I guess. So the reason they put this here, I think, is because they want to make sure that the program actually executes without an error. Let's see. The program executes without an error. Because if they didn't have this here, I can't take it out. Anyway, let's see this. Oh, I needed to input something. Sorry. 250. Oh, okay. Did I? But if I don't have this here, I just get an error, I think. So 250. See, there's an error. All right. So anyway, what's next? Arithmetic expressions. Okay, this is the right side of an assignment statement, the right side of the equal sign, and you can have an expression. You can have a whole thing that where you do the calculation, you compute it out, and it ends up being something that can be stuck into the left side, the variable on the left. So there are these operators. There's addition operator, subtraction, multiplication, division, this exponent, we've seen these. And what's a valid expression? X plus 1, yeah, that computes to something. 2 times x minus y in parentheses, that computes to something. This computes to something. So does this. This does not. This is just a 2 followed by an x. The computer won't understand that. You have to put a little asterisk in between there. The computer won't understand 2. It'll say, oh, the guy wants to make a variable that's starts with a 2. That's not going to work. So anyway, so that's not valid. And same here, there's got to be a asterisk in between the x and the y. And then this is not an expression. This doesn't compute to anything. This is a statement. This is an assignment statement. This does something. It this thing, you execute this thing, it computes this thing, stores it into y. So anyway, so that's not valid. So here, these exercises here are because you have to get good at hearing. Oh, total days divided by 12, and you go, oh, that's this. 6 plus number of items. You got to know to write to. Oh, that's what that means. That's how you'd write it in an expression. 6 times the number of items. 5 times t. You wouldn't write that. That's not what you write. You'd write 5 asterisk t. The negative of user value. Yeah, that's what you'd write. And there's no. This is not an operator in Python. So you have to use that math thing that we talked about earlier. There's actually a factorial function in that math module, which we'll get to later. But so this is not a valid. It doesn't have this symbol for anything. So there's also these things called precedence rules, and like if you've got something that looks like this, The parentheses makes it so you would you'd add these, you'd add 1 to x first, and then you would multiply that by the 2. If the parentheses were not there, then the multiplication would take precedence. You do the multiplies before you do the pluses. Okay, that's the multiplication operator has precedence over the addition and subtraction operator. The parentheses of the highest, and then after that you have the unary, the minus sign in front of something. So like, for example, this. First you take the negative of x, and then you multiply that by the 2. And then this has next precedence, and these are multiplication, division, and this modulo operation, which I don't think we've covered yet, but that's the remainder. If you divide one number by another number, you get a dividend. You get a quotient and a remainder, and so this percent is what is how you get the operator to get the remainder of a division operation, which turns out is real important and useful in programming. And then this is multiplication and subtraction, and then after that it's just left to right. So like multiplication and division have the same operator precedence, so there's no rule about doing one before the other. So then it's done left to right. First you do this one, then you do this one. Turns out it doesn't matter. All right, so go through this if you want to. So anyway, you can go through that if you want to see how that plays out. Here's exercises in parentheses. You always do what's inside the parentheses first. You know this. Okay, so this one, x plus. Okay, so first you do the 1 times y, then you divide that by 2. That's y over 2, and then you'd add that to. Okay, so first you do the 1 times y. This one. Then you do. So it's this one. First you do the 1 times y, then you divide that by 2, and then you'd add the x to it. So here we have a thing. We have this thing called number of items, and that's 5. So that's this thing. That's 5. And what's total count? Well, first of all, we do 5 times 2 is 10. So then we have 10 here. And then we do the times. So 10 times 4 is 40. And then we add 1. So that'd be 41. So it's this one. Here's an example where you might be given this expression, and you're supposed to write a program to do this, and you know that this doesn't work. Really, what that is more parentheses. Yeah. So these are kind of fun. Match the changes that were made. There's more to this. Sorry. The x multiplied by that. Age, you might want to be more elaborate. Weight in pounds. Heart rate. What else? Yeah, so space in variable names was replaced by underscores. These were replaced by parentheses. Minus sign was replaced by that. And the x was replaced by that. There we go. All right, you can do that. Python expressions. Okay, so this one, okay, so this is, here we're figuring out leasing costs or something. You got 3 inputs. Copy, paste, save, run, enter down payment, $5,000. Enter monthly payment, I don't know, $100. Number of months, what is this? What am I doing anyway? I have no idea what I'm doing. Leasing cost, oh, down payment. Oh, this tells me, this might tell me how expensive a car I can lease or something with those kinds of payments or something. I don't know. Whatever it is. Okay, well, but what we're supposed to do, well, let me just use these numbers. Down payment 500, monthly payment 300, 60 months. I can buy an 18,500 or something. Okay, great. Okay, so anyway, would removing the parentheses as shown below have yielded the same result? Yes, it would have, because the parentheses don't do anything. Multiplication has as operator precedence over addition, so regardless of the parentheses, you would do the multiplication first. So yes, it would have yielded the same results. Would using 2 assignment statements as below have yielded the same result? Okay, so what we're doing here is first we're multiplying these 2 things together, and we're creating a new variable called all months cost, and then we're taking all months cost and adding it to the down payment, and that's what total cost is. So it would have yielded the same result. Yes. Okay, here they're trying to tell you that you should put 2 spaces around every operator, and that is completely up to you. I personally think I like smallness, so I like it. But anyway, yeah, don't put commas. All right, so you can do those. Here's figuring out printing again. Oh, we're supposed to put this. Acceleration of gravity. We're supposed to compute the acceleration of gravity. It's this, huh? So acceleration of gravity equals somehow this. And it's going to be g times m divided by, what's d? D is the distance in meters. Ah, this is it. It's this. Okay. So that's d. And it's got to be squared. Okay, so I can do a times times. Okay. See if this works. Yes. All right. Okay, so anyway, next is division and modulo. So division is like, you know what division is. Looks like this. Okay, this is obviously that. This is 50 over 50. 5 over 10 is equal to 0.5. That's just this single slash. When you do the double slash, you're only getting the quotient part. So 5//10 is going to equal to 0 because it's only because it's you truncate everything to the right of the decimal point. So it's an integer. These are bad examples, but this is going to be 12 divided by 4 is 3. Am I supposed to do this? Yeah. Okay. This is 0.5. This is 0. Oh no, this is 2. This is just 2. I guess you need the 0.0. Huh, okay. And this is going to be error. Bam, bam, bam. Can't divide by 0. Okay, and modulo just gives you the remainder. So 24 mod 10 is like 24 divided by 10 equals, 2 with a remainder of 4. 1 divided by 2 is 1 with a remainder of 1. So that's modulo. And here's an example of where modulo is used. It's to figure out the so here, let's say you're given a bunch of minutes and you want to figure out what it is in hours and minutes. So you enter 75 and it ends up being 1 hour and 15 minutes. So we take the hours is equal to the minutes divided by 60. And you notice it's not 75.0 minutes. But. So anyway, and then you take this 75 divided by 60 is, 1 with a remainder of 15. And when you're doing modulo, you just keep the 15, the remainder. All right, so you should be able to do that. 50 mod 2 is 0 because it goes in evenly. It's 1. It's going to be 1 left over. And then the one's 10. This is just going to be 8. This is just the lowest digit. When you're doing by 10, it's just the lowest digit. So this is 6. 1 divided by 2 is 0. So 100 mod 0 is an error, I believe. Yeah, and this is right. All right, so you can do that. This is an interesting thing here. Here shows how you can do a bunch of that like that to get like the prefix of a phone number by dividing and modding and dividing and so on. All right. Then we have modules. Modules is just a way of having a bunch of files, having more than one file for your Python program, and having one file include or call another file. So here we have an example of we got a okay, here we just have some dumb program which is called print name, and it says first name equals Larry, last name equals David, and then it says print hi, comma, first, comma, last, and when you run it, it just looks like that. Whatever. But you could have this. You could have one file that just defines first and last, and then you have another file called print name, and you import the first file, and that's just like including that right up and replacing it with import. So the key word here is import. In other languages, it's called include, but and there's other languages that call it import also, but so this is import. And so, so it's like this was executed. So you can say, you know, oh, and the way you refer to them is, since this comes from names.py, we refer to it this way: names.first and names.last. That's where it came from. So you use this dot notation. So a file containing a Python code that is passed as input to an interpreter is called a script. And a file containing Python code that is imported by a script, module, or interactive, that'd be a module. And then used to reference dot notation, and import executes the contents of a file containing Python code. All right. There's a way that you can figure out if you know, you're executing out of one of these files. There's a way to figure out if the file that's executing is actually being imported into another Python file, or it's actually the Python file that was executed, you know, by the user. And it's you test to see if the name is got it's this underscore name, but you know, this is it. I think it's too early for us to talk about this. Okay, so we should talk about this after we understand what this if equal is. So let's just skip this, but you should be able to still answer the question. So I mean, you're just gonna have to take this on faith. Okay, so so let's say you run this. If you run it, then this is going to be true. So it's going to print out, you know, if you at the command line run this. In fact, we can test it, but I'm not going to. It's going to be, if you run this from the command line, then this part is going to execute. So you end up printing, that comes out. However, if you run this one at the command line, that's this one. This is going to import this. So it's going to import this, and it's going to execute this, but it's not going to execute this part. It's not going to execute this part because it was not, this program was not called by the user at the command line. This program was called by some other program right here. So since this program was called by some other program, this is going to fail, and so this will not execute. So when this thing is called by the user, then this thing executes, but this doesn't, but this does. And then this down here prints this out, and it refers to the Earth G and Mars G over here. Anyway, so what is printed out is this thing. So it's this is what's printed out. Anyway. And then there's this math module here, which has got a bunch of stuff. It's got a square root function. It's got a power. This to the power of this. It's got ceiling, you can round up. Factorial, there's the factorial function. Oh, it's just called factorial. It's math.ceil, math.factorial. This is the remainder of a division. Isn't that no mod? Exponential function. This is power raised to the power. This is arc cosine, tangent, arctangent, cosine, hypotenuse, radians, hyperbolic cosine, and so on. A bunch of them. There's constant pi, constant e. So that's so these are all things that are in the math function. See, this is how you use them: floor, power, so on. So you can go through those. All right, I think representing text. Okay, it's good. You got 4 minutes left. Any questions? No. Text characters. Each character has a character code. Unicode. Okay, this is the character. So, for example, the decimal encoding of the left curly brace character, that's this one, is 123. That's pretty easy. And then you can escape out these things. It's called. So if there's a backslash character, if you actually want to, like here you want to print out this thing here, right? This name equals John O'Donnell, but O'Donnell has an Okina or a single quote in it, and using single quotes to define the string. So if you put a backslash there, then it's like you actually want a single quote there. You're not ending the string. So it prints out like this. See here you're using double quotes, but you also want double quotes inside the string, so you put a backslash there, and it'll print out like this. A backslash n is like a line feed. See, so it skips to the next line. Tab, backslash t is a tab. So here we tabbed in. We skipped to the next line, then we tabbed in. So that's why it's skipped to the next line and tabbed in. And so here you can kind of figure out what these are. All right, so it's 428. So you should be able to go through these things, and next time I will go through some of these exercises here to get you going on them. All right, are there any questions? Does this look pretty easy for you? Oh, should we print out the code? 10.2. Oh, 10.2. You know, you don't have to do anything extra. Is that what you're asking? You just have to, you know, do these exercises, and then it's recorded. How do I know that? I don't know. I don't want to show you. I don't want to show you the data, because then you'll see other people's data. You know, I don't want to do that. But so I have this, you know, how much participation and so on, and for challenge and participation, you just got to do them until you get what they're trying to teach you. Yeah, you shouldn't have to memorize anything either. You can always have reference. You can always as I go through this, I'll point out places where you can quickly find answers on Google. Of course, there's Python.org, but there's other ones like W3 like Python format function. So I look here and let's see, W3 schools is a good one. Real basic, simple stuff. And here we find there's different ways of doing the same thing that we were doing before. These are different kinds of format things. Here we're printing this out. But so anyway, okay, all right. Yeah, so yeah, you shouldn't have to do anything. Just do everything, enter everything into the thing here. And it turns out when we do get to the when we get to am I stuck? When we get to some of these labs here, I'm going to show you like what this means. And this textbook is designed to try to really to try to reduce. They've spent a lot of time thinking about how to reduce the the urge to cheat, and I guess cheating is a real big deal. There are tools in here which will help me compare to see if you guys copied each other. Okay, so like if one of you writes some code and then copies it out and puts it in an email and sends it over to somebody else, and that other person just takes that and copies it and puts it in, then this thing will be able to detect that, and it'll do things like, yeah, they changed the variable names, but that's really all they changed. Well, I don't want to get into that. Okay, so I have my own ways of reducing the urge to do that. One is if you ask me the question, you don't have to ask me the question very many times before I'll just tell you what the answer is, or I'll show you what the answer is, and when we're done, you have the answer. Also, I try to remove the time pressure. So if something comes up and you can't get it in by the due date, you can hand it in later, and I don't take off any points and so on. But these kinds of things, it's a signature of your work, and this is what I did earlier. Okay, so this shows what I did earlier today. 9/1, which is today, which is a Tuesday. Each dash is each time I clicked run the program in developer mode. Each time I click run the program in developer mode, I get a dash. Okay, and then whenever I submit, when I click over submit and I click run program or click submit, then there's a vertical bar and it tells me the score. Okay, well, you notice here, I did a bunch of things 4 times, and then I submitted, got 0 points, and then I went back and I did a developer run again, and then I submitted again, I got 0 points, and then I went back and I did a developer run again, and then I submitted and I got 10 points. Okay, so this is a pretty common kind of profile, because what I'm doing is I'm just trying stuff here. And what I did here, this is my answer, I think. You're supposed to, this program, you're supposed to enter in the 2000, and then you're supposed to divide it by 2 and display that out, and then divide it by 2 again and display that out, and then divide it by 2 again and display that out. And so what I did was I started by just doing one of them. I just did one of them and to see if that works. And then I added another one to see if that works, and I got this and this one. And so that's why there's a couple of them there where I know I'm going to get 0 points, but I'm just trying it out. And so that's sort of, so I want to kind of see you, I'd like to see you develop your code in this thing, and I'd kind of like to see this kind of thing where you try out stuff. You just try the bare minimum, and you get something. Oh, that's what I expected, and then you add more, and you add more, and in the end you have the points. So I guess if you are going to help each other, think about this, okay? And just to actually get this kind of results, you're going to learn something anyway. So. All right, so I'm past the time. I will stop sharing. So I will see you on Thursday, and if you have any questions, just let me know. Anything else? All right. See you next time.
Thank you.